investigators of the Student Project Scheme of Kerala State Council for Science, Technology and Environment, supported by Department of Science and Technology, Government of India. Out of 500 students, 395 students registered for this webinar. I hope all are in the final lap of preparation for the project submission. The research methodology is a specific procedure or technique to identify, select, process and analyze information about a topic. Today, we have with us Dr. S. Pradeep Kumar, Member Secretary, KSCSTE, Dr. Mahesh Hariharan, Professor, School of Chemistry, Indian Institute of Science, Education and Research, Reinventing Sri Arjun Prasad, Scientist, KSCSTE, and myself, Dr. Anil Kumar, Senior Principal Scientist, KSCSTE. On behalf of KSCSTE, I welcome all the participants. I invite Dr. S. Pradeep Kumar, Member Secretary, KSCSTE, to formally inaugurate the program. Sir.
Thank you, Anil. Kerala State Council for Science, Technology and Environment cordially invites all the invitees as well as the students to this webinar. KCST started different webinars on different subjects on the wake of this COVID-19. This webinar is mainly for the orientation of our students selected under Student Project Scheme of DST sponsored program. Today the topic selected for the webinar is research methodology. Research simply means searching for that which already exists on pursuing the truth. When we talk about the research methodology, we not only talk the research methods, but also consider the logic behind the methods we use in the context of our research study and explain why we are using a particular method or technique and why we are not using others, so that research results are capable of being evaluated either by the researcher or by others. I am not going too deep into this topic. For that, we have an excellent expert in this area, Dr. Mahesh Hariharan, Professor at School of Chemistry, IISER, Trivandrum. That is, we are very proud to introduce you because you are the first young scientist awardee of Kerala State Council for Science, Technology and Environment. Welcome, Dr. Mahesh. I invite Dr. Arjun Prasad to formally introduce Dr. Mahesh Hariharan to this webinar. Thank you.
Thank you.
Thank you.
Good afternoon to one and all, dear friends. It's indeed a great pleasure to have you all here. And we have today we have a special speaker, as our Honorable Member Secretary mentioned. He is the first Young Scientist Awardee of our council. So, introducing Dr. Mahesh Hariharan. He is a professor at School of Chemistry at IISER, Thiruvananthapuram. After completing his doctoral research from CSIR List, Trivandrum, with Dr. D. Ramaiah, he carried out his postdoctoral research at Northwestern University under Professor F.D. Lewis. And his research area or research focus is primarily on understanding the interaction of light with biomolecules, crystalline and twisted organic materials. He is the recipient of several awards at national and international levels, including Chemical Research Society of India Bronze Medal in 2020, Japanese Photochemistry Association Lectureship Award for Asian and Ocean Photochemistry, sponsored by Aiko Shah in 2020, and several other awards, including our Kerala State Young Scientist Award in 2013. He has featured in several journals, reputed journals in chemistry, including Chemcom, Chemistry European Journal, and Journal of Physical Chemistry. He is also very much interested in teaching and has given more than 200 invited lectures at different universities and international conferences since 2009. On behalf of KCST and all the participants here, I cordially invite Professor Mahesh Hariharan to this webinar. And over to you, sir. Thank you.
Thank you, Dr. Arjun, for kind words of introduction. And I also thank Dr. Anil Kumar for taking this initiative in organizing a sort of tutorial session on research methodology. And I also thank Member Secretary, KSCSTE, the opening remarks, and feeling that there is a need to teach the students about research methodology, and therefore organizing this particular lecture. So, what I'll do for next 1 hour or so, let me thank Arjun for kind words of introduction. Let me also thank Dr. Anil Kumar for taking this initiative to organize a course on research methodology. To begin with, it's a 1 hour session. And let me also thank Dr. Pradeep Kumar, Member Secretary KSCSTE, for taking this initiative to have an excellent lecture series on research methodology for the postgraduate students in science and engineering. So let me begin discussing about two aspects in this topic. One is research, and the second aspect is the methodology. So as we go by, we will get exposed to these terminologies more and more and think about it in greater details. Before I begin, this is the campus that I work in. It's in the middle of forest in Vidura. So this is an aerial view of School of Chemistry. That's where I am sitting now in one of these rooms. And this is how our campus looks in the night. So those who are interested in visiting IISER Thiruvananthapuram, feel free to shoot a mail, and you can come over and see the facilities that are available, and the opportunities that are available also can be understood with some discussions with the faculty members. Yeah. So the discussion on research methodology that I am going to have today is primarily taken from one particular textbook. So I will convert this pointer option to a writing pen option. So this is the topic that you see here. And it is a book that is written by Professor C.R. Kothari, and it is available from New Age International Publishers. And this is an easier those who want to make this topic lighter. But there is also a book that is available, which is often followed in many of the universities in the United States. It's called The Craft of Research. And the fourth edition is something that I have taken some of the information and the figures, etc. So let me go by this particular textbook so that it is easier for you. And the topics that are handled over here are research problem, hypothesis, outline of research plan, research proposal, methods of data collection and management, numerical analysis of data, research report, ethics in scientific research. It includes plagiarism and related case studies, and presentation of research work, and safety. You could even think of more important aspects that could be added into research methodology topics, but this is only a guideline to begin with. In a 1 hour lecture, you will only get a glimpse of many of these things. You will not be able to cover all of these aspects. At IISER Thiruvananthapuram, we offer a course for this is for the PhD students, and it is a 12 contact hours, 0 credit course. This is quite interesting to note that it is a 0 credit course, which means that by taking this, students will not get any credit, but this is a course that is insisted by MHRD and UGC that the students must be taught about the research methodology, how to conduct research, what are the essential of research methodology, and also various other aspects that you see here, some of which I will be covering today, the most important ones. Yeah? And after the end of the discussion, I will send this PowerPoint presentation to the organizers so that this can be made available to the students who are in need of that. So as you can see, the book that I am following is shown underneath as the reference that I have taken. And there is an OSU safety manual for the safety section and also prudent practices in the laboratory for the laboratory type research. So you can see that it's quite interesting for research methodology. There are books available on many types of research that one might. I see that the crowd here are mostly science students and the engineering students. So this book may be a perfect fit that some of the topics are common to all of you, but some are topic specific. Whether depending upon whether you are doing an analysis on what type of plants that are growing in northern Kerala or what plant type of plants that will survive in southern part of Kerala. If this is the kind of study that you are doing, then it will involve lots of statistics in it. And there are lots of numerical analysis to the statistics that one could do, which is what is covered in sections like this. Now let us assume that you are not working on an open field or a kind of ecological hotspot type areas, but instead you are working inside the laboratory, then you should be paying more attention to personal protective equipment, safety data sheet, types of hazardous chemicals that you are dealing with, chemical segregation table, standard operating procedure, prudent practices in laboratories, importance of waste that are generated from the laboratory and how do you manage them, how do you dispose them, become more important. So there are certain topics that are specific to a particular kind of researchers will not be covered in today's discussion. But certainly I would be happy to have either an online session or an interaction session in whichever colleges you are. That if you want to know more about it, I'll be happy to discuss that one on a later day. And that will not be covered in today's discussion. So let me go forward in asking a question, what is research? So you can see research can be defined in various different ways. So let us assume that somebody is asking you that kind of question. How will you answer it? Some would say that research refers to a search for knowledge. Some may say that research means a scientific and systematic search for pertinent information on a very specific topic. It can be a very narrow topic, but then you accumulate lots of scientific and systematic information, and that becomes over time a very massive document that whoever wrote that document will become an authority in that particular topic, and that can be on any topic. It can be history of Kerala or history of Trivandrum or history of churches in Kerala or history of temples in Kerala or the availability of titanium in Kerala. I mean, you can just take any topic and do a rigorous investigation. It becomes, a research topic. In fact, research is also an art of scientific investigation, which means that you want to scientifically prove something and you take up research as your career and then start investing your efforts into focusing the investigation in a particular direction where the scientific story is unfolded through your research. Now, purpose of research is to discover answers to questions through the application of scientific procedures. So, one parameter that you repeatedly see that research involves is a very clear scientific procedure. And this scientific procedure involves lots of methodologies, and that's what we will be discussing today about research methodology. And for that, you need to know some more terms that are quite often used among ourselves, but then there is little bit of definition to that in first few slides. So let us know who can be called as scientist. Yeah, usually what we do is that somebody who has a position called scientist in an organization, we call them as scientists, but that's not how scientists got involved. There could be scientists in you, there could be scientists in your friend, there could be scientists in your younger brother, there could be scientists in your younger sister, or there could be scientists in your grandparents. So there is scientists in everybody. And what is the term scientist imply is one, engaging in a systematic activity to acquire knowledge. And that's why I say that, or lots and lots of books say that scientists are there in everyone. Right? You just take each individual, there is a scientific mind, scientific curiosity, and people try to acquire knowledge. But there is a systematic way of doing that one, which is being taught in many of the organizations, and that is a discipline in your life. You tend to become an organized scientist that others will also start calling you as scientist. And that's what we are going to discuss a little more in greater details. So, motto of the Royal Society of London, established in 17th century in in the UK by Robert Boyle, a very famous scientist, and Newton, various other people who were at that time practicing scientists. And they came up with a phrase called nullius in verba, and that's what you see here. And what do they say is that don't take anyone's word for anything. So scientists mean somebody who will not take anyone's word for granted, but instead will think deep into those proposals or assumptions and then figure out the truth behind that. And this was one of the initial description about being a scientist. And the main principle of science is that the experiment is the best test. So anything that anybody is trying to make a remark, the most important aspect is to test it out and make the test as rigorous as possible so that the truth comes out of it. And that's where the research methodology gets stronger and stronger. The more you have experiments, the more it gets stronger. Yeah. Now, Galileo called his experiments as simenti, which is trials by ordeal, which also says that you do lots and lots of experiments and you may suffer for that, but at the end the truth comes out of it. And this was Galileo's description of simenti. I'm sure that all of you are aware of what Galileo has contributed to science. He was one of the strongest scientists to say that Earth revolves around the sun. And during that time, any of the religious beliefs would not believe that the Earth is going surrounded by the sun, but people felt that sun goes around the Earth. Yeah. So through various experiments, Galileo came up with an argument that the truth is Earth goes surrounded by the sun, and whether you believe it or not, that is true. And for which Galileo had to go through lots of suffering because he was speaking against the understanding of that time. However, as you can see that Galileo became popular for generations afterwards. Now, centuries have passed by. We know Galileo for the strong experimental conviction or scientific conviction in his research methodology that he had, because of which people appreciate Galileo and also the truth that he has discovered. Study of science is also not something to take for granted the approved body of knowledge. Maybe sometimes your textbooks will have some things that are not right, so you can question. But if you question them, you should have law to say that what is being shown in the textbook is wrong for so and so reason. You cannot just blatantly say that a body of knowledge that is available. For example, Newton's laws of motions are completely wrong. That is not how you say, but instead you have to chart out the reasons for the claims that you are making. And if a set of people who are called reviewers, they are also called peer reviewers, which means that who are expert in that area, collectively sit together and say that, what you have told is right, then your theory becomes important and the existing theory can be questioned. And there is a very clear procedure that is available in science in order to test all the new hypotheses when we say that the older hypothesis is wrong. Yeah. So let me go forward. The strength of science is that it has provisional nature, and this is something that you have to be extremely appreciative of. Means that in science, people are always open-mindedness to listen to others. That something that I am believing for last, let us say, 30 years, and there is a young person coming and telling that whatever thinking you are at the moment is completely wrong, and I have the following reasons to tell, then one listens to it very carefully with all the open mindedness and then analyzes the entire process and then resets the knowledge in a way that whatever most updated and correct information will be the information that is taken forward. And that's why I refer this as provisional nature, which means that it is always subjected or it's always flexible to get corrected. While this is not something that you would see in formats of things which are not science, wherein you have some belief and you have to believe that and you never can change that. That is not how things happen in science. And most importantly, there is a capacity for doubt and uncertainty, which means that if you don't have today sufficient experimental evidence, you leave that particular topic with lot of uncertainty and lots of doubts rather than saying that this is all established and we are aware of the fact. So there is scope of lots of ignorance that we have, and associated to that the knowledge can be incomplete, and associated to that there can be lots of doubts and uncertainties that one can have. So this is a peculiar strength of science and scientific methodology that one would always appreciate. Now, Richard Feynman on science has been commented, and you can see adventure into the unknown, an unknown that must be recognized as unknown in order to be explored, and that is the humility of the intellect, which means that you have to realize that there are lots of things which are unknown. We have to embrace in order to make it explode and then finally get to a point where we know about it. And there are several things that we still can know and better our information. And to have this kind of character, the most important aspect is to have humility in the intellect, rather than telling that I know everything in the world. One has to have a feeling that of course there are many things that I am unaware of or the scientific community is unaware of. So through humility only you can tackle that and get going forward. So let us see what are the motivation of scientists. Yeah, desire to understand the world, strong curiosity about reality, recognition by their peers and prestige, desire to apply scientific knowledge for the benefit of people, nation, and the global prosperity. And these are the main aspects that scientists usually would take up. And people like Einstein, Rousseau came up with the fact that we have physicists, we have geometers, we have chemists, we have astronomers, poets, musicians, and painters in plenty, but no citizens. So this is a very strong argument, and you can see why this is being told, and this has been repeated in the history by various people. Despite the contributions of several scientists, there are problems associated still with respect to energy and environment, water, food, poverty, terrorism, so on and so forth. Yeah. So let us take a quote from our own father of nation, Mahatma Gandhi. The things that will destroy us are politics without principle. I'm not reading each of them. There is one strong argument that says that science without, which means that in research methodology, it not only tells that you do research, and what is the methodology, it also says that you have to do it with some amount of humanity, or rather larger amount of humanity, then the science is complete. And these days, there is also yet another issue that is coming up, and that I will summarize during the end of my discussion, which is science without principle, which means that there are lots of unethical contexts that destroy the name and the reputation of the scientist, which also one has to be careful. As you people are growing scientists, you have to be extremely careful that all these aspects are important. The scientist should have a very good character, good morality, good humanity, and good principles. All of that is essentially needed, like any other discipline would require, like politics or business or worship. You take any of them. Yeah. So let me go forward to describe more about research methodology, which is the topic of discussion today. The types of research study are classified in several forms. This is not really comprehensive, but this will give you a guideline like to understand what are research methodologies, and you would take it from here to read little more in order to understand further. Yeah. So to gain familiarity with a phenomenon or to achieve new insights into it, you call it as an exploratory or formulative research studies. And these are generally like, you want to understand a phenomenon, why apple is falling down, or why a lighter balloon is going up, or why tides are coming. All of these are some sort of phenomenon that you see and you want to know more and more about it. Yeah, and this falls under exploratory and formulative research studies. Now, there is yet another way of describing research is to describe accurately the characteristics of a particular individual, situation, or a group. And these are descriptive research studies. You may have seen people telling that, a group of people are experimented to see if you drink coffee in the evening, will you have sleep or no sleep? Yeah, these are typically descriptive type of researches, and they are not phenomenal like the one that you see in the first part. Yeah, so descriptive research are generally a kind of analysis of group behavior or individual behavior or situations, etc. Now, the third type is a diagnostic type research, which means that you have, you to determine the frequency with which something occurs or with which it is associated with something else. Which means that, every year rain comes at a designated time. And then when rain comes, you see that there is an associated event that is happening. And that associated event that people are trying to study is what you can refer as diagnostic research, which means that there is a field because of the rain, this is happening. So people get into more and more investigation to see whether there is a direct influence of rain on that particular happening which we see. There is yet another way of doing research, which is to test a hypothesis of a causal relationship between the variables, and this is what you call as hypothesis testing research studies. Here we say that because of a particular parameter, there is yet another parameter that is getting affected, and you want to see whether these two parameters are related in some sense. And that's what you call as hypothesis testing research studies, wherein you have ahead of time a kind of relationship that you are assuming that it exists, and then you are doing the experiments. Yeah. So these are the classification of the way that people do research, and these are some research methodologies. Yeah. Now, just to give little more flavor to the things that is being discussed, descriptive research includes surveys and fact-finding inquiries. The main characteristic of this method is that the researcher has no control over the variables. He or she can only report what has happened or what is happening. So it is just purely an observation based research, and the researcher does not have any control to tune the experiment, which means that let us assume you are doing a research. What will happen to a farmland when continuously that farmland gets 30 days of rain? Yeah. So you don't have any control over how much rain that can fall on the farmland, and you cannot control the amount of water that is collected in the farmland, because rain is something that we cannot control. Similarly, you can do experiment with availability of light that is falling onto a land, and then how much is the light controlling the productivity or the yield that is coming with respect to tomatoes or potatoes or some harvest that you are interested in from this land. There is a possibility that you can do analytical research. On the other hand, the researcher has to choose facts or information already available and analyze these to make a critical evaluation of the material. For example, let us talk about coronavirus. Now, there are several places where the coronavirus infections are large in number, and several places it is not large in number. Now you can do an analytical research as to why this is happening, and then you have a logical interpretation to these numbers can be called as an analytical research, which means that there is already a set of facts that is available. Now there is yet another way of doing research, which is applied research, that aims at finding a solution for an immediate problem facing a society or an industrial or business organization. A very nice example is that during the Second World War, most of the fuels were cut down to Germany and never was supplied to Germany. And Germany came up with an indigenous way of preparing the fuels within the country, and they are named as processes that you would know, which is called Fischer-Tropsch process or Bosch process, etc. These are all indigenous way of synthesizing fuels, which was not supplied to the country to stop war by the other countries. And not necessarily all the time your applied research has to be related to war. There are several other applied research. For example, if you want to find a drug or a vaccine for coronavirus, it can be called as an applied research rather than for the sake of understanding the fundamental aspects of protein structure. So applied research is also an important aspect. And then the final form of research is what you see here, is the gathering knowledge for knowledge's sake is termed as pure or basic research, which means that how electrons are orbiting around the nucleus. You want to know about it is for the sake of knowledge that you want to gain. And this is also an important form of research, because sometimes the basic research over a period of 100 years, you would see that it will translate to applied research and it becomes fundamentally important to the mankind. Yeah. So all these forms of research are important in some sense. So it is the community or the government or the people decide how much attention has to be given to each form of research that or analytical research or applied research or basic research, etc. So let me go forward in order to discuss even more important aspects of different types of research. Attitude or opinion research, that is research designed to find out how people feel or what they think about a particular subject or institution, is called qualitative research. Even this research can be conducted carefully to figure out how to handle a particular situation, which can be a situation which can create damage to a larger public. So what you do is that you keep on asking several people and then gather information, and collecting that opinion, you would come to an argument that this could be a solution to the problem that we have. And this qualitative research is also has helped solving many of the problems that existed. But not all the time all forms of research will be useful. It depends on what is the kind of problem that you have. Now, empirical research is a data-based research, experimental type of research. Such research is thus characterized by the experimenter's control over the variables under study and his or her deliberate manipulation of one of them to study its effects. And this is what many of the laboratories wherein people have a control over, let us say, you increase the temperature and see whether a temperature of the room and see whether a flowering plant will flower the same way when it is in different temperature. Let us say that you have a cold room which is 0 degrees centigrade or a cold room which is 5 degrees centigrade, and you slowly warm that up to 10 degrees centigrade, 20 degrees centigrade, 30 degrees centigrade and 40 degrees centigrade. And you want to ask a question, will the flower come out of the plant in all these temperatures, or is it temperature dependent process? And this is what you call as an experimental type of research or empirical research. And largely many of you will end up doing the empirical research, but some of you may end up doing qualitative research and various other research forms that we have discussed. And I will not spend longer time on each of these. This is to give you a flavor like how one can describe different types of research. There are research like one-time research or longitudinal research. You have field setting research or laboratory research. There are simulation researches that you can think of, which is done, using a modeling parameters that are entered either into computer or you just simulate and then come up with the research that you are doing. There is a possibility that you can do clinical or diagnostic research purely related to the hospitals and the medical centers. You can have historical research to see, like, a particular type of human beings. You can call it as Neanderthal men, when they lived, in what time scales they lived, and what was the form of clothing they had, what is the type of food that they ate. These are classified into historical research. You can have conclusion-oriented research. Sometimes, some research do not conclude, it is open-ended. And you can also have decision-oriented research, which means that at the end of analysis, you have to make a quick decision and then get going in order to do something which will save the mankind. So all these forms are exciting in some way or the other, and that people use. So considering that I have to cover different aspects, I'm going into research proposal now. And you can see here that one of the most important aspects of research methodology is to plan your method of research, and that is often done by writing a research proposal. And that is what I'm going to discuss for about next 10 to 15 minutes. And you will see that they are fairly described here, and it is taken from the textbook that I have shown in the first slide. Now, any medical research or epidemiological research, and there are various other forms of study also, should have a proper proposal in written form before it is actually carried out. This is a very important aspect that each of the students should embrace, that the research proposal or the methodology with which that you want to do research has to be actually written down before you start the experiments. You should have a plan like what you are doing. And it is like a blueprint of a building plan before the construction starts. Yeah? Which means that you have not built the building, but you know how the building will look like. And that's how you start with your research proposal. Now, at the end, when you conduct the research, you may end up getting that is totally different from the beginning. That is all right. But to have a plan is an extremely essential thing. Now, writing a research proposal is both science and an art. That is something that we will evolve over the next few slides. And a good research proposal is based on scientific facts. This is something double underlined. You see that scientific facts on the art and on the art of clear communication. This is also that I am underlining. And two parts of today's discussion will be split, where how important is to have scientific facts presented and the art of clear communication. So all I am going to talk today will be based on the research proposal, how to present scientific facts, and the art of clear communication. And these are three important parameters that you will see will appear in the rest of the presentation over and again. Now, writing a formal research proposal should be started by the time one has decided on the topic of the study. Let us say that any of you in your class decided to study that how butterflies move from one location of your college campus to the other location of the college campus, depending upon the weather that it changes. And this is something that you have decided to do the research. It might be your interest just to explore that one. Now you may ask, what is the application of doing that research? Definitely it is, when you are beginning, it is not an applied research, but no one knows when it will become applied. Yeah. So let us go forward. The first part will be the objective of the research proposal, which means that you will make sure that your research proposal has a clear objective. You want to know how you can achieve that particular objective. Then you say a scientific justification, which means that why that particular thing has to be studied at all. Then you introduce that particular topic, and you go on to collect literature on what others have done, which is what you call as review of literature, is extremely important. I will come back to that point in another few minutes. And then you will narrate methodology, which is what is referred in this entire talk called research methodology. And then you will have time frame and work schedule, which is what you call as Gantt chart, and that chart examples I will show in the coming slides. And then whether you need any people to do the experiments, or you yourself will do that one, or you are doing it based on the data available, you will describe all of that. And what are the facilities needed? Do you need a camera, or your phone camera is already sufficient, or you do not need any camera related gadgets, but all you need is a sound recorder. Yeah. And things like that. I'm sure that many of you know not all the birds when they fly will make noise. Yeah. For example, owl will not make noise when they are flying. Now, if you want to study that, the facility that you would require is a kind of sound recorder to the delicate activity that you have, wherein you want to find out the owls are not making any sort of noise with the recorder that you are recording. While many other birds, when they fly, they make noise. Yeah. So now the question is that why owl is not making noise when they fly? This can be a question that you want to study. So that will be your objective. Yeah. Justification is that you want to make an aircraft which is not at all noisy, and that's what you want to make by studying the owl and how do they do that one, and mimicking that one to a device which will make a flight, and that flight doesn't have any sort of noise when they are flying. So there is no noise pollution. You can also introduce the topic by telling that this is extremely important to have your flight noiseless to reduce noise pollution, which is for the benefit of the larger mankind. But you can also say that if you want to go to your enemy's area without any noise, you want to use an aircraft, and that has to be noiseless, and that's what you would do in introduction. Now, the background or the review of literature will be, did anybody study this already? If people have not studied that one, then you study with lots of interest. But if already somebody has studied, you would want to know what is that they have studied. And then from there, you would want to know whether is there anything more that to be studied, or everything that you need to know, whether it is available in the literature or not. And if it is already available, then there is no scope of further things to do research. It is all done. So review of literature is extremely important to know whether you need to spend time or not. Let us say that people have not studied the flight of owl, and as a result, you want to study, you want to describe the methodology. How will you come up with the methodology? Like you have a stand here where you make your owl sit, and you ask the owl to move from here to here by keeping certain insects that owl will eat. So owl will fly from here to this point to take this particular food that is kept here. Now during the fly, when the wings of the owl are moving, you want to see whether anything that is kept here is moving or not. And you keep things which are very light, like feather, yeah, or you keep cotton, or you keep pieces of paper, yeah. Anything that you keep here, you will notice that if the owl wing is moving, that particles that you are keeping here, like feather, cotton, or paper, they will all move. And how much they move, from that you can figure out how uh, how much of the sound effects that it creates in the vicinity, that it can create little bit of movement here, the kind of waves that it creates, because of which you can see that things are moving. So it creates limited ripples in the environment when owl moves. So not only that it doesn't make noise, it also doesn't disturb the waves that are surrounded by it. So to study the methodology, you have described the methodology. Now the question is that how long it will take in order to study. Do you want 1 day to do research, or you want 1 month, or you want 1 year, etc. You have to clearly tell why do you need that much time. Yeah, and that is a question mark that you can see here. Now, do you need people in order to study this? For example, if you are sitting with the owl here, do you want somebody to sit here and do the measurements together? Or you alone will be able to manage when the owl is moving from this point to the other? And that describes whether you need more personnel in order to do the studies. Do you want any peculiar facilities? Do you want a place where larger number of owls are available, and you want to grow larger number of owls, and you want to study them between the age groups where it is in 0 to 2 months, or it is 2 to 4 months, or all of the owls behave in the same way, so on and so forth. Now the final and important aspect for research methodology is that for doing all of this, do you require any sort of budget? Yeah, whether you need any financial support to do this research, and if yes, who will give that financial support to you? And for that, you have to find agencies, and there are lots of government funding agencies that can support your research, provide the scientific committee feels that all that you are telling in these lines are important. Yeah. So you can see here that these are the important aspects of research proposal, and I hope I have taken sufficient time in order to explain this, and I will be really happy to discuss even more of that if it is essential. And let me go forward to describe what objectives can be. Like, how do you define objectives of your research? I have taken a simple example of an owl movement, but there can be lots of other things that you can study. Now, objectives are very important and pivotal section, and everything else in this study is centered around it. For example, what is that you want to study is what you call as objective, and this, when stated, rest of the proposal will flow along that line. And that is why it is called pivotal section, which is the most important section. Now, the objective of the proposed study should be stated very clearly. We have to tell what is that you are going to study, and why is that you are going to study is also equally important, but it is called justification. But all of that comes under the purview of the proposal. Now, the objective stated should be specific, achievable and measurable. Like, sometimes you want to really have very difficult proposals that you are proposing, and they are generally non-achievable and non-measurable, then the people who are trusting in you will not be able to fund you because these are non-achievable and non-measurable. So they have to be extremely clear with respect to what is that your objectives, and your study should have very limited number of clear objectives instead of having too many objectives. Yeah, so you can see here that even just one clearly stated relevant objective for a study would be good enough, but you have to be very clear to state that you want to know what is the finest particle that is available in matter, and this is what you want to study, and your objective is very clear. Whether the smallest form of particle is molecule, or the smallest form of particle is an atom, or the smallest form of particle is an electron, or the smallest form of particle is something which is below the size of an electron. All that can be your question, and that will be your objective in order to study them. Now, that means that you have one clear objective in order to study, and that is what you will be trying to pursue. And if there is more than one objective, the objectives can be presented in the appropriate order of importance, which means that primarily I want to study that, and then as a subsection I want to study yet another objective, and then yet another objective. If time permits, I would like to study few more objectives, and there should be a priority with which you are presenting them. Now, your proposal or the methodology that you are coming up with should have an introduction, and there you define like what precisely that you want to study, and you introduce the topic. The problem proposed to be studied is introduced in this section. It should help the reader to acquaint with the topic. Introduction should be short, about 1 or 2 pages. Don't write too long introductions. It has to be very clear that what is important in this particular area of research that you are pursuing, and why you want to do that. And the problem should be stated in such a way that its importance and relevance is realized by anyone who reads it. And your introduction invokes people to understand that what kind of research that you are going to do is essential. Primarily from the introduction it comes. Yeah. Now, the background is what I have told, review of literature, and I want to introduce a phrase here, reinventing the wheel, which is something that you all know that wheel has been invented long back, right, by the Greek scientists and philosophers, and you know that wheel is a form of a kind of device that you can think which reduces friction. So the moment you attach wheel to any object, you see that you can roll them easily. Now the question here is that if you don't know who invented this or whether it has been invented or not, you may as well say in your proposal that you are going to invent the wheel. And that is where this phrase comes from, reinventing the wheel, which means that you don't know that wheel has been already invented. You end up proposing that you are going to invent the wheel. And that is not acceptable. And that is where you tend to review the literature thoroughly and establish the background. And once you know the background, you will not claim that you know whatever others have already invented. And this section reflects extensive review of literature done by the investigator. And the more review you know, more stronger your proposal is going to be. In this section, what is already known about the topic is written, including the lacunae, which means that there is a lot being done, and you will say that this is not done, and I want to try it, and that is acceptable. Like for instance, you will say that wheel of this kind is known, wheel of that kind is known, but wheel of a particular kind is not known, and that is what I am trying to work around, and that is acceptable. Yeah, just quoting the literature verbatim will not serve the purpose, which means that you do not take the entire literature from others just like that, but instead you have to rewrite the entire thing in a way that you are presenting it as an original document. It is important to make it coherent, relevant, and easily readable knowledge for the people who are reading it. It helps the investigator to gain good knowledge in that field of inquiry. So it not only helps the readers, it helps the presenter also to know a lot about the topic and then present it in a cohesive manner. It also helps the investigator to have insight on different methodologies that could be applied, which means that some people tackled the making of the wheel in a particular way, and some people have studied the owl's movement in this particular way. But then I am studying the owl's movement in a particular way. I am studying the wheel construction in a particular way, and that you will be able to present provided you know what others' methodologies are available. And it is extremely important to do the review of literature in order to make sure that you are doing new things. Now comes the research methodology in a greater detail. Research methodology is a way to systematically solve the research problem. It may be understood as a science of studying how research is done scientifically. It is necessary for the researcher to know not only the research methods, techniques, but also the methodology. And this is extremely important to see that the method of research is also being carefully understood, not just the technical side to it. And researchers not only need to know how to develop certain indices or tests and how to calculate the mean, the mode, the median, or the standard deviation or chi-square, etc., and the details how you do that. It is essential to discuss procedures clearly and completely with considerable amount of details. That you have to say that this is the way that you are going to do. And that methodology description is extremely important to see whether your proposal will get through or not. Yeah, there are important things that are related to studying population or sampling specifications, etc., and the sample size that is needed. I'm picking one example for the study design. You can see a study design is a specific plan or protocol for conducting the study, which allows the investigator to translate the conceptual hypothesis into an operational one. The study design should be clearly stated, and the study design to be used should be appropriate for achieving the objective of the study. Now, one can talk a lot about sample specifications or study population or number of experiments that you want to study in order to make sure that what you are studying is authentic and the information that you are gathering is authentic. It is important to describe which would be the study population, how study subjects would be selected, randomization process, and other details should be given. Now, it is also important to declare the sample size. It is important to mention in the protocol what would be the minimum sample required and how it is arrived. Let us say determination of sample size is a bargain between the precision and the price, which means that, let us assume that you want to study a particular behavioral pattern in a rabbit, and you want to do the experiment on 50 rabbits or 500 rabbits or 50,000 rabbits. It is always accurate to do the experiments on 500,000 rabbits if possible, but the price is going to be huge. It is easier to study on 50 rabbits, but the precision is going to be compromised. So you come at a bargain between the precision and the price by choosing, let us say, about 500 rabbits, and then you will end up getting fairly accurate results, which is a bargain between these two parameters. Now, the description of process. The proposal should include the details of all process to be adopted in the study, how exposures, outcome variables, and other variables are going to be measured should be described in greater detail. A brief description of how the data will be processed and use of statistical package, if any, should be given. What kind of statistical tests of significance would be used, and all of the details that you are doing for your analysis and the research has to be part of your proposal, which will naturally translate to the output document which you are generating, which is what you call as manuscript, or the paper or the thesis that you are preparing for your exams or whatever. Now, the time frame and work schedule often are not important at the student's level. However, it is also a good practice to always come up with a time plan in what time scale. The proposal should include the sequence of tasks to be performed. I will show a Gantt chart here that will tell you like what it means to have a time frame and work schedule. So you can see here a Gantt chart is shown, which I have taken from the internet, identifying research area. Let us say you are doing it over September. You have research questions, and that you do in October, and formulate research strategy, research design, and select methods. You do over October and November, and write research proposal by 15th of November, and you negotiate access by November, and you make sure that you do heavy load of literature review by November and December, and then you collect data over December and January, and the collected data you want to analyze, and that you do in the later part of January. And with the analyzed data that you have, you want to write a first draft, which you do in February, and and you can write your second draft. After writing the first draft, it becomes little bit not so great, and you want to write a revised draft, and that you do in March. And finally, you come up with writing a final draft, which you do in the April, and your dissertation submission is on, let us say, April 21st for whatever degree that you are pursuing, or you want to submit the manuscript to a journal by 21st of April. So you have from September to April a time chart that you are following, which is extremely important for any research methodology and proposal part. There are examples of that I am showing here, all taken from internet over a period of several years or several weeks, etc. Now, if you need facilities, you have to describe that. I have already mentioned. If you need personnel for doing your research, you have to mention in your proposal. If you yourself are personnel, then you can say that you are the one to conduct the research. You need to mention what is the budget, and the budget includes usually the salary for the person who is involved, the travel, if there is any, then the purchase of the tools that you require, then you want to print and Xerox the documents that you are generating, and then consultancy charges, and also the institute, if supports, you have to provide some sort of return to the institute, which is what you call as institute overheads. As students, probably this is not important to you for the proposal part, but the other important aspects are narrated here. Now, referencing is quite important, and that is what the next part of my discussion is. I probably would take yet another 5 to 10 minutes before I conclude. And the referencing part, which means that if somebody has already figured out this, the research that you are doing, or part of the research that you are doing, appreciating them is very important. And this could be a person from Europe or United States or Japan or India or whoever. Appreciating others' contribution is an important aspect in research, and that is also something I will be discussing in the next few slides. So roughly the same aspect will be there for your PhD research proposal, but there is no budget part here. Introduction, your specialization opportunities in, let us say, some processes that you are going to work, and then the methodology, validation framework, work plan, status of work, and then references. And the earlier research I told is for any kind of scientist, and this is for the PhD students, and you can read little more in this direction, how a PhD research proposal would look like. Now, coming back to the point, two important aspects: ethics in science and communication. So you can see here, ethics in science is extremely important. It comes from the word ethos, which also means that it's character in English. So ethics meaning you have a strong character while you are doing science, which means that cheating is not allowed. So why ethics is important in science? The entire method of conducting and propagating science is based on the faith of the ethical integrity of the practicing scientist. So one who carrying out the scientific experiment should be honest, and the objectivity has to be very clear, and one has to be careful in doing the experiments, which means that out of ignorance one should not make errors. And the cheating is something that is never allowed, and that is why the word ethics is extremely important, which is related to character. And why scientists don't cheat? Usually, you see that 0.01 percentage per year is confirmed cases, which means that it is a very small amount. Which also means that the scientists are ones with extreme high integrity and honesty that you see here. And that is an essential quality in scientists. And that comes from people who moderate each other. So scientists are often, controlled by other scientists. So definitely, cheating will not be allowed by the peer reviewing process, and that's why you see that there is not very many cheating that happens. And in general, why people don't cheat is also something that you are aware of. There is no happiness that one gets by cheating. It's only those who do not want to do hard work will always cheat. So generally people are hardworking, so there is no cheating. So we don't have to worry too much of that. However, there are some guidelines that are important, which I am going to discuss. The ethical guidelines come in different ways. One is like, research of the kind that you are going to change the human behavior, things like that, that can be questioned as unethical. And that whether to be done or not has to be vetted by several group of people. So that is one format of ethics that one could think of. Another type of unethical processes are, let us say you are an author of an article and you are submitting to a journal where you yourself try to act as a reviewer, then this is clearly a form of cheating that you are coming up. And there is yet another way that in order to have your PhD thesis or MSc thesis getting accepted, you pay money for that, and that is yet another form of ethical misconduct that one can think of. There is also yet another type of ethical misconduct where you cheat with the data that you are producing, and that has been seen in the literature. And if you type this particular name of a German scientist called Jan Hendrik Schoen, you would find that there are lots of excellent papers Professor Schoen has published, but there were lots of fraudulence in the data that he had presented. And this is unacceptable to scientific crowd. And when this was exposed, all of the papers that were published by Schoen is being retracted. And you can see here, all of these papers are retracted, which means that they are not anymore scientifically valid documents that you will see. Yeah. So this is the kind of action that people take, fraudulence in science, and these data are completely misinformation, and it is not to be believed. Now, there is yet another misconduct that people can come up with is plagiarism, and that is something that we have to be extremely careful as students, and I will tell you why. First, we will see what is plagiarism. It comes from the Latin word called kidnap, which means that you are lifting something from others, which means that literally the word plagiarism comes from the root origin that is related to thief. Yeah. So one may steal money, one may steal some objects, but stealing words and information from others is also a theft, and one has to be extremely careful on that. And that is what you call as plagiarism. And that is something that has to be extremely controlled and taught in academic institutions. Because if known, people would not generally do. So sometimes it happens because of the ignorance that people are not aware of it. Yeah. In short, not giving proper credit for using someone's writings or words. Yeah. Or different forms can be purposefully stealing someone's work to pass along as your own. So, what is plagiarism? Is simply explained here: the practice of taking someone else's work or ideas and passing them off as one's own. So, never that has to be done. And there are different forms of plagiarism. One is called global plagiarism, and you can see presenting an entire text by someone else as your own work. It is of severe mistake type, and one should not do that. And there is also paraphrasing plagiarism, which means that you rephrase someone else's ideas without referring to that original person. It is a serious offense. One should not do that one. And verbatim plagiarism, which is directly copying a passage without citation, and mosaic plagiarism, which is combining text and ideas from different sources without citation. So somebody is smart enough that you have 10 documents and you use one line each from all these documents, and the combined one is claimed as your document, is what you call as mosaic plagiarism. There is self plagiarism, which means that you write one poem and you become popular, and after some time you write another poem which has the same set of information that you had from the previous poem, and that's what you call as self plagiarism. That is also not allowed. And incorrect citation, which means that what is being discovered by Newton, you say that it is discovered by someone else, is also called as plagiarism, which is an incorrect citation. So you can easily now understand what are the forms of plagiarism and how to avoid plagiarism, understand what constitutes plagiarism, learn what does not constitute plagiarism. First thing you should know. So you go back and try to understand what we discussed. Check out the rules regarding copyright and learn how to properly cite references and learn how to paraphrase, and you review, make sure that there is nothing that is being taken from others, and take advantage of your own professor's knowledge, give the document to others, ask them to read, and there is nothing that is taken from others, make sure that it is not copied. And one such example you will find. I have taken this entire thing from elearners.com, and now I have cited that in the bottom of the page itself. And this is not taken from two textbooks that I have discussed. So I decided to put the source of information, which is elearners.com, from where I have taken this particular material. I hope this was very clear to you, like how to avoid plagiarism. And you can see one example that I have taken from the New York Times, published in 1986. It is a newspaper cutting. And then the New Republic, yet another paper that was published almost 7 months later in 1987. You can see several sentences taken by Zakaria from Trainer, and you can see how these sentences are. The ones that are colored will have same colored, will have some similarity. So I will read that one. Colonel North was to have returned to marine duties 2 years ago, but remained with NSC at the request of Robert C. McFarland, who was the president. It goes further. Now let us read the same colored text here. North was scheduled to return to the Marine Corps in 1984, but McFarland made special request to extend his term for 2 successive years. So which means that they are roughly the same kind of information, and without citing the first author, which is Trainer in the New York Times, Zakaria goes on to use the information in the New Republic. And this is unacceptable, and this is what you call as one of the plagiarisms that you have seen in the previous slides. There is yet another form of plagiarism that you would notice here, which is a clear plagiarism, which is in 2011, California spent $9.6 billion on prisons and $5.7 billion on higher education. Now you read it here on the right side. In 2011, the California spent $9.6 billion on prisons versus 5.7 billion on higher education. Isn't it exactly the same sentence that is being copied and kept in this particular paragraph? So this is also not acceptable as plagiarism, and one has to be extremely careful. And I will end the presentation and by telling that communication skills are extremely important in research methodology, and that is a topic that we can discuss at a longer length at a later stage, and that is also something one has to be extremely careful, otherwise we will end up having plagiarism. Most of the time when we don't have writing and presentation capability, what do is that we copy from others and then present it, and that has to be extremely controlled while you are presenting a thesis that you claim that you are the owner of that thesis. So let it be a publication, thesis, presentation, posters. Your capability to communicate is essentially important, and you have to have proper credits given to the source from where you are taking the things, which is also extremely important in research and research methodology. A naturalist's life would be happy, one, if he had only to observe and never to write. This was written by Charles Darwin. People often refer that Charles Darwin was a lousy writer. He always wanted to observe, but never wanted to really describe it. Although he has written Theory of Evolution, a long document, he never wanted to write, but he wanted to go on to observe. But this has a catch that in science, no matter how spectacular the results are, the work is not completed until the results are being published, which means that if you don't write on the research methodologies and the research results that you are getting, it means that you have not conducted research. And when you are writing, you have to be extremely careful that you should not be copying it from others. So I will not elaborate further. It's getting too long. I will just skip off the rest of the part that I have, and I will possibly end the lecture by saying thank you, and my email ID and the phone numbers are given, and you can contact me at any time with the questions and I will be happy to answer. Yeah, so in nutshell, what I wanted to discuss today is the research methodology, in which how to describe a research proposal and what are the objectives, introduction, and the methodology layout that you are going to have, and what are the requirements that are needed in order to carry out research, and how one should not end up having unethical code of conduct in carrying out research, and then how important is to have communication skills in order to communicate the research results that you have obtained. This is a synopsis of the course that I am teaching, which means that it is shortened to 1 hour, and each of these topics can be elaborated longer, that if you wish to, you can contact and I will be happy to share the notes and discuss that in a greater detail. Yeah. So with that few words, I am stopping now, and I will be happy to answer any sort of question that you may have.
Thank you, sir. Thank you. I think it was really painful to cut short the 12-hour classes you take into 1 hour.
Yeah, I have chosen the important ones, but as I said, all of these can be expanded. So depending upon the availability of the students or depending upon the need, sometimes you don't need to learn all of them. It is you only need to get a flavor of that, and then expand in a way that you can clearly do your own way of analysis and then get going. So I made sure that all of that is being covered in necessary amounts, but certainly each of that can be expanded in a greater detail.
Okay, I think we have received a few questions.
Sure, I'll be happy to answer.
So first one is kind of general, like what is the real difference between a scientist and researcher? They both invest on a particular topic.
Sure, I mean, those two are interconnected, so definitely I didn't use them as a separate word. A researcher and scientist are essentially one and the same. They do highly focused and scientific investigation based on facts, and both collect facts in order to arrive at conclusions based on the facts that one would have. And it is extremely important to have experimental evidences in order to make conclusions. But those conclusions, depending upon the way that is being analyzed over time, can change depending upon how you conduct the analysis. But it is very important that your experiments are true for generations, and that should never change. And both are done by researchers and scientists. They are essentially the same. If I have confused by telling that they are two different terminologies, they are not. They are one and the same.
Then another question regarding is there a difference between a research statement? Are they the same? It's kind of.
Pardon me? There is a difference between
the research proposal and research statement. That's one.
Yeah, that's a very good question. So, research statement, often, let us say there are lots of students who are aspiring to go to, let's say, United States or Europe or Japan or some institutions in India for doing research. You write a page, 1 page or a 2-page research statement. And in that research statement, you only mention that, what has prompted you to think about research as a career, and why would you want to pursue research. And research statement often do not take you to particular aspects of research that you want to do, which means that you are not pinpointing at exactly what you want to do and how you want to do. While research proposal has to clearly have all the components that I have mentioned now, without it is incomplete. And a research statement is often not expected from serious scientists who are on the lookout of financial support, etc. While research proposal is not expected from young students who are on the lookout of getting a PhD position. So these are two separate aspects that are expected from different set of people. So likewise, as you can see, research statement is often expected from students who are going to make their career forward, and they write research statement in order to say that I have the research aptitude and I am thinking in this line in order to take my career as research. And what prompted you to do that? And that is what has to get reflected in that document. It may be something you made a hydrogen balloon in your young age, and then when that was bursting, you wanted to know why it bursts. Or you were walking along the ocean and the coastal regions of ocean, and you felt that why ocean is blue, and that can be a kind of reason why you want to take up research, and that can be a research statement. But research proposal is very precisely coming on to the point: what is the problem, and how do you define the problem? Whether that problem is addressed by someone else, and if not addressed, which way you want to address it, and after addressing it, how it is important for others, and in order to address that one, what is the support that you need to get, is what you call as research proposal. So it's a very precise document in order to explain the research plan that you have.
Thank you, sir. The next question is regarding when does a research becomes an applied research, and what is the major difference?
This is a very interesting question. During the presentation itself, I was giving a cautionary thing. Many of you know Compton effect, right? Which you study in +1 or +2. When Compton himself was carrying out that research in early 1900s, which is about 100 years back, people thought that it is going to be a fundamental research. But if you wish to know, today Compton scanning is an important scanning in order to understand whether tumor exists in our brain or not. Yeah, and there is a methodology with which you can get a clear idea about what are the kind of tumorous bulbs that are present in various parts of our body through Compton scanning, which comes from Compton effect. So in principle, there is nothing like basic research and applied research. Research that gives you some form of results, and if one is smart enough in applying it somewhere, it becomes applied research. And if it is not applied anywhere, it remains as fundamental or basic research. But never it says that fundamental or basic research will not transform to basic, transform anytime. Sometimes it happens in 1 month, sometimes it happens in 1 year, sometimes it happens in 100 years, sometimes it takes even more. So you never know that, and because of which you cannot distinguish them, very clearly. They are entangled one. They are one and the same. This is at least my perspective, and I'm sure that there are many who believe that.
In connection to that question, actually, so while writing or while doing a presentation on your research proposal,
Yeah.
you cannot see an immediate application.
Yeah.
How we will scientifically justify our research proposal?
Okay, so always scientific research proposals are appreciated by mankind in two different ways. One, you classify them as fundamental research, and the other one, with immediate applications, you call it as applied research. So, fundamental research will mostly divert the attention of the research towards something which is very fundamental that mankind has not explored so far. For example, you want to know something which is related to how the motion of electrons surrounded by the nucleus, that people are still studying about it. Yeah, and that you would definitely call it as fundamental research at the moment, and it is not going to immediately have an applied aspect in next 1 year also. While the applied research on the other side, for example, finding a vaccine for coronavirus, is going to be something that is an immediate thing that you are on the lookout of. And when that happens, there are huge number of people who are going to benefit out of it. You would define that one as an applied research. However, sometimes a drug or a vaccine for coronavirus does not come overnight in an applied format. People might have been working for 50 years in some protein, and they suddenly see that this protein is killed by accidentally or by design by a drug, and that drug will become a vaccine or a drug to the problem that we have. And then again, that is a fundamental research that was happening immediately got translated into a product or an applied research. Yeah, but certainly while writing, you can distinguish them by whatever you claim is being vetted by certain amount of scientists surrounded by. So they also have to accept that what you are telling is right or wrong. That is why this tested research, experimentally tested research, are the ones that stand for longer time. The one that survives for longer time are the ones which are appreciated by other fellow scientists as well. So things will not get easily escape from the people who are judging it, and that is an extremely important aspect in scientific research. It is judged by the experts with necessary expertise, is what you call as peer review process, and it is extremely important. And that will also say whether it is an applied or a fundamental research.
Thank you, sir.
Yeah.
Another question is regarding how, does a scientist require management skills?
does scientists require?
Management skills, like
Management skills.
Yeah.
Of course, I mean, like in any other profession, no doubt, scientists have to manage their time. There have been instances where intelligent most scientists in the history have been seen to have poor management skills, because of which some of them died at an earlier age because they did not even know how to manage their diet. They did not know how to manage their daily living. They did not manage their hygiene, so that they were infected by various diseases. So that aspect on one side. Another aspect is managing time, and another aspect is managing people. Definitely managing skills is important for any human being, not only scientist, in order to be successful. So it is not a bad idea when you are young, read management books in order to have proper management skills. This all comes down to certain level of discipline that one has, and from that, you are able to manage your time, manage your friends, manage your fellow colleagues. It's all important. I fully agree with the student or whoever asked that question. Management is very important in science.
So I think it's the final question. Just curious, because our participants are majority from the postgraduate students
Yeah.
who has interest to pursue further studies.
Yeah.
I think many of, especially when you were also in that experience, when you wanted to pursue higher studies, you would have so research problems in your mind, like and how one should narrow down it to a particular area. I mean, it's quite critical, I guess.
It's a very interesting and complicated question to answer. Possibly, what I will do is I will take my own life experience to explain this. Students may not know a very popular faculty from Kerala University. He's a chemist. His name is Professor K.N. Rajashekaran Pillai. And when I was doing my MSc, I was fortunate to listen to one of his lectures in Muatupura. I am originally from Cochin, and I ended up listening to a very nice lecture by Professor K.N. Rajashekaran Pillai. In short, he is called KNR. And he gave a lecture on combinatorial chemistry. Yeah. And that evening, I must tell that I ended up feeling that is the end of the world, and I should be doing research in combinatorial chemistry. Yeah, he was giving fantastic lecture there, and then I started feeling that if I get an opportunity, I would definitely do research. But that literally sparked my interest in doing research for sure. And then I started exploring. But the second part of your question is that, whether that is what I continued later is definitely no to that question. Answer is no. Because I ended up exploring various places, and I found that as I got entered into a particular research group, there are various fascinating things, not just the thing that I heard. And I got interested later in yet another aspect, which is called photochemistry. And this is something from a research lab that I got exposed, which was largely generated by Professor M.V. George, who was a legend in the country, with the help of 5 younger scientists. And all of them were at that time flourishing with this concept of photochemistry. And one such name is familiar to KSCSTE is Professor Suresh Das, who has been one of my teachers, to expose me to different forms of photochemistry and related aspects. And I would say that during our young age, we get interested in doing research, but not the topic that we will be probably pursuing in our longer run. Topic will evolve over time depending upon what is the available resources that we have in the surroundings. But the interest towards research will get sparked when you get to listen to speakers of various kinds that you get to listen in your young age. And this is something that I have personally gone through. But definitely this will be different for yet another scientist who wanted to do research in, let's say, theoretical physics from standard 7. I have heard them telling that, they have gone to ECG Sudarshan's group and then did experimental physics research with Professor Sudarshan, worked on that particular topic to make major breakthroughs. And that is yet another way of doing. I think it's very personal depending upon the individual's life, which way you get to see the legends that are surrounded by you and through which your interest will slowly get modified. But your scientific aptitude and scientific spirit will always remain same, that you want to really do something and contribute something to the society, and that will definitely be there. I hope I answered your question without confusing, and this is the best that I can give.
I understand. It differs with persons, different experiences.
Yeah. Yeah.
I think we are getting really late, so I'm trying to skip a few questions. I'm sorry, dear participants.
No problem. Yeah.
Thank you, sir. On behalf of KSCSTE, I would like to extend our sincere gratitude to Professor Mahesh Hariharan for giving us a wonderful lecture on research methodology today. And thank you very much, sir.
Thank you, Arjun, and thank you, Professor Pradeep Kumar and Professor Anil Kumar. Thanks.
Thank you all the participants.
Thanks all the students for listening.
I know many people are couldn't join the webinar. I hope we can do something, some other session or something.
Sure, you can just get back to me, and definitely we can have more discussions.
I would also like to thank our Executive Vice President, Professor K.P. Sudhir, and our Member Secretary, Dr. Pradeep Kumar, for helping to organize this session.
Thank you.
Bye.
Thanks.
Okay, thank you, Mahesh, for an excellent.
Thank you, sir. Thanks.
Thank you.
Thanks.
Sir, shall we conclude?